In this lesson, we are going to talk about proportions. Proportion is an equation that states that two ratios are equal, such as 8/10 is equal to 4/5. Proportions are useful for solving for an unknown. For instance, what over 5 is the same thing as 6 over 15? Well, to find that, I just have to think, well, what will get me from 5 to 15 with multiplication or division? 5 times 3 will get me 15. What times 3 will get me 6? Well, that would mean x would equal 2. The simple approach may not be sufficient when working with more complex proportions. For instance, if I have 7 over x equals 10 over 7, 7 times what will give me 10 isn't something easy to figure out. It would still work, but it's not as easy. So we've developed a rule to accommodate more complex problems. That rule is called cross multiplication. Cross multiplication states that if I have a fraction a over b equals a fraction c over d, then a times d is equivalent to b times c, and it makes an x, so that's why we call it cross multiplication. Let me show you why that works. So if I have a over b equals c over d, why would that equal a times d equals b times c? Well, that's because we're getting rid of the denominators. We're multiplying by b d on both sides, b d, and then the b's cancel on the left, and I get d times a, or that's the same thing as a times d through the commutative property. And then on the right, the d's cancel, and I get b times c. And that's why that works. So it's just a simple way to solve these problems is to multiply across and set them equal. So for instance, if I wanted to use the cross multiplication to solve for x in this problem here to the right, all I would need to do is do 10 times x, 10x, and multiply 7 times 11, which would give you 77. Again, the reason why this works is I can multiply both sides by the denominator, 11x, the two denominators, and this would cancel the x's out and the 11 out, giving me 11 times 7, which that's where the 77 came from, and 10 times x, which would be 10x. Then I could divide by 10, and whenever I divide by 10, that just moves the decimal place over 1, and I would get 7.7. So that's how cross multiplication works. So where are some real life instances where we can use cross multiplication? Let's look at that. But before we do, let's review what proportional means. In geometry, two shapes are proportional if they look the same, even if they are different sizes. So right here I have two pictures of myself. One has just been copied. These are proportional because they look the same. They're still proportional if I change the size. So these two would be proportional. However, if I copied it again, but I only changed one dimension and not both, this third image would not be proportional to the other two images because it does not look the same. It's not in proportion with the other. I could also take that same image and distort it vertically. So basically, things are proportional if they look the same, if the image isn't distorted from the original. One of the most common examples is finding a missing height. In this picture, we have the sun casting a shadow on two trees of different heights. The two triangles created by the shadow are proportional. They're the same shape, but not the same size. So let's look at how we would set up a proportion. So we're going to compare two things. We're going to compare height, and we're going to compare the length of the shadow. So the height of the first tree is unknown, so I'm going to put an X there. And the shadow length is 17.5 feet. I'm going to set that equal to the other side. So again, height of the tree, let's draw a little picture of the tree there. The height of the tree in this case is 10.5. And the shadow is 11.25. So we're going to use cross multiplication. So I do x times 11.25, which will give me 11.25x. And then I'm going to do 10.5 times 17.5. So I'm going to use my calculator. So 17.25 6.5 times 10.5 would equal 183.75. Then I'm going to divide both sides off by 11.25 to get x alone. And that would give me 16.3 repeating. So I'm just going to round that to 16.3. So x would equal 16.3 feet. Now, I want to make sure that that makes sense. So 16.3, if I write that in here, that should be taller than the smaller tree, which it is. So that would make sense. So if you got something lower than 10.5, you know you set up your proportion incorrectly. So make sure you do those last checks.